Hello everyone, welcome back to my YouTube channel, and in today's episode I'm gonna show you how I built a RAG application able to interact with any of your PDF documents. This application is built using LangChain as a framework to connect all the components. The dataset is ingested in 𝘀𝗀𝗯𝗲, which is an amazing vector store database for searching similarities between documents. I'm also using Groq for its fast inference, so we could get the responses of the large language model really fast, and we could use a large language model such as Llama 3 with 70 million parameters, and I designed the front end using Streamlit. And let me quickly show you how this application works. So if we click on the button 𝘀𝗀𝗯𝗲 vectors update, it means that we will either create or update our vector store database with the documents that we have saved in a directory. So let's do it now. Let's click on it, and here we can see that all the documents were successfully added into our vector store database. So we can proceed to ask any type of questions to our large language model. The PDF that I uploaded to 𝘀𝗀𝗯𝗲 is a document that have the football rules. Here you can see it. It has 144 pages with unstructured data and tables and figures. So let's ask a couple of questions to the large language model and see if it's able to retrieve information from this document. Let's ask, for instance, how many players does a football team have? Here, let's click on generate response and see. Amazing. Here we can see that it is working as expected. It mentions that the football team has a maximum of 11 players, and one of them is the goalkeeper, which is great. And it even mentioned which rule specifies the amount of players that a football team can have. Let's ask a different question, such as, what's a free kick? What's a free kick? And let's see the response. And here it specifies what is a free kick. And now I will show you the workflow of this application. So the first step is to load the data. Here we have the documents, and the documents mean a PDF document, so we can have as many PDF documents that we want in a directory, and we proceed to load them to a vector store database. But first we need to split them into chunks, because large language models have a context window in which they can process X amount of tokens. So if the amount of tokens that this document have is larger than the context window, the large language model will not be able to process it, and therefore we will need to split into chunks each one of these PDF documents that we have. So we split them into chunks, and we will create embeddings. For this case, we will use an open source embedding model that is located in HuggingFace, and this model will basically transform each chunk into a numerical representation in vectors in a vector store database. In this case, we will be saving all our vectors of embeddings in 𝘀𝗀𝗯𝗲. If you're enjoying this content so far, don't forget to subscribe to the channel by clicking on this button, because it helps me to create more content. Smash the like button below and turn on the notification bell so you never miss a new video. Therefore, when a user asks a question such as how many players are there in a football team, the first step will be to create an embedding of this question, and we will use the same model that we used in the previous step from HuggingFace, and we will perform a similarity search, trying to identify relevant chunks to this question. So we will aim to identify the most similar chunks to this question. After identifying the most similar chunks to this question in this vector store database, and we will feed those retrieved chunks to our large language model. In this case, we're using Groq for the fast inference, and the large language model that we will utilize is Llama 3 70 million parameter model. And then the large language model will generate an answer that will be sent to the user. And now I'm gonna show you the code to build this application. So the first step will be to create a virtual environment that will contain all the Python libraries that you need in order to run this application successfully. In this case, I have installed all these Python libraries that are used for the front end or to streamline the workflow of this application, to read environment variables. HuggingFace Hub and LangChain Groq is either for the inference of the large language model or for creating the embeddings where we're saving the data, so it's in 𝘀𝗀𝗯𝗲. And PyPDF is to work with PDF documents. Also, you will need to feed environment variables in order to run this application. I have them here. In this case, you will need HuggingFace Hub API token in order to create the embeddings. Also, you will need environment variables for 𝘀𝗀𝗯𝗲 in order to insert the chunks of those PDF documents into the vector store database. And also, you will need an API for Groq in order to use the large language model. I'm going to be leaving in the description below a link where you can get all these API keys. I have all the code in the source folder. It contains an app.py and also another Python package with the common functions. In this case, I call it utils.py. So let's see it in details. Let's click on app.py, and here we can see the Python libraries that were important. So the front end is designed using Streamlit, and here I have a couple of functions that I created in the utils.py The whole idea of creating these functions in the utils.py is to have an app.py with a higher readability. And now let's go through the code. So we will define a function that will contain our Streamlit application, and the first step will be to define the page config. Here we specify a chat PDF and then a magnifier. So if we go back to the Streamlit app, we can see here at the top in our tab chat PDF and the magnifier. Also we specify as a header chat with all your PDFs, and then this robot, here we have it at the top as a title, and then we proceed to incorporate a filling box where the user will type the question. In this case, we add streamlit.textInput and here specify ask a question from the PDF files. And here we can see this filling box where the user can type the question. We go back to the code, then here we get the embeddings. In this case, I'm getting HuggingFace embeddings. So let's check the function. Here we can see that we're getting the embeddings from HuggingFace. I paid my HuggingFace API token and also the repo that contains the type of embedding that I want to use. In this case, I want to use 𝗀𝗂𝗯𝗀𝗲 L6v2, and this function basically will return the HuggingFace embeddings that I will use later to transform the texts into embeddings. Then I specify a sidebar, which is this one in the left, that will have update or create vector store, and then this button that will trigger the first part of the workflow, which is ingesting the data into our vector store database in Quadrant. Here we have the title of our sidebar, which is update or create vector store, and then here we specify the button. So if we click on this button, Quadrant vectors update, here we'll have a spinner that will say processing when these two functions are executing, and when they finish, we will display a success message saying done. So here we have data ingestion and Quadrant add documents. Let's check them both. So we go to data ingestion. We can see that we use this function from launching, which is called PyPDF directory loader. Here we specify the path of our data. So here we can see that we have it in the data folder, and we will get all the PDF files that are in this directory. We will load the data and then we will split it into chunks. Here I specify that I want chunk size of 800 characters and an overlap between the chunks of 200 characters. Here I have an explanation of the chunk size and the chunk overlap. Since I specified that I want a size of each chunk of 800 characters, here we have our first chunk, so it will have 800 characters. And since I specified that I want an overlap between the first chunk and the second chunk of 200 characters, so the last 200 characters of first chunk will be the same as the first 200 characters of the second chunk. And then you will have the same pattern on the subsequent chunks. So the second chunk will also have 800 characters, and the last 200 characters of the second chunk will be the same as the first 200 characters of the third chunk, and so on. So that's the meaning of the chunk size and the chunk overlap. And then after we specify the text splitter, we will split our documents. So we're splitting our PDF file into chunks that will have a size of 800 characters. And those chunks, we will upload them to Quadrant. So let's check the function of Quadrant. Here we specify Quadrant add documents, and we feed as argument the HuggingFace embeddings and the documents that we want to upload. So let's click on the function. The first step will be to do a client connection. And here I specify that I want to connect to Quadrant, and I need to provide the Quadrant host, which is one of the environment variables that we have, and the Quadrant API key. And then we can get the client connection. So after we connect to the client in Quadrant, we need to proceed to create the collection. So in order to create the collection, you will need to provide as arguments the collection name. Here we have Quadrant collection name, which is one of the environment variables that we specified earlier. And also we need to configure the vectors of our collection, which I have here. Here I specify the length of my vectors, and also that the distance that I want to use is cosine similarity. In order to know the size of the vectors, I specify here the length of my embeddings. So I provide a string, in this case is how are you, and then I calculate the embeddings of this string, which is basically the numerical representation of this text, and then I calculate the length of my vectors. You need to take into consideration that this length of the embeddings will vary depending on the embedding model that you are using. In this case, I'm using an embedding model from HuggingFace, and it has a length of 384. So after we create our collection, we proceed to create our vector store, in which we need to specify the client connection, the name of the collection, and the embeddings that we will be using. So in this case, we will be HuggingFace embeddings. And then we proceed to add the documents to the vector store database. So we get the vector store, and then we add the documents. So if we go back to the application, we can see here that we're feeding two arguments: the embeddings, which are the HuggingFace embeddings, and the documents, which are the splitted chunks of the PDF document. And then if we keep checking the code, we can see that we have another button, which is called generate response. And we will use this button when the user asks a question and we want to know the response. We also have a spinner that displays thinking while all these functions functions are being executed. Here we can see that the first step will be to connect to the database and get the most similar documents. And as I said before, we will transform the user question to embeddings, and then we will check the most similar embeddings in our vector store database. So let's click on this function, which is quadrant get documents. So in this function, the first step will be to connect to Quadrant and get the client connection, and then we proceed to connect to our vector store. We specify the client connection, the collection name, and the embeddings that we're using. So with this function, we'll be able to connect to our vector store database. Then we're loading our large language model, so let me click on this function, get LLM. Here we can see that I'm specifying that I want to use chat Groq. The temperature, which is basically the creativity of the model, will be 0 because we want to have something as objective as possible. And then we specify as model llama 370 billion parameters. Also, I need to specify the API key of Groq. And finally, we have here the chain that will connect the large language model, our vector store database, and the user question. I specify here this template in which I say that the large language model should make a concise answer, and also if you don't know the answer, just say that you don't know and don't make up any answer. Also specify the context, which are the retrieved documents from Quadrant, and also the question. And then we use LangChain to define the prompt template, and we specify here the template that I just mentioned before, and the input variables, which are the context and the question. And then we use retrieval QA, and here we need to specify the large language model that we're using. As a chain type, we add stuff, and this is essentially a summarization technique that will essentially take all the information of the chunks. Then I specify a retriever from the vector store, and I'm using as a similarity 3 documents. Also, I'm gonna return the documents, and also I specify in chain type quarsh the prompt that we saw earlier. And then I'm getting the answer of the results. Now let's go back to app.py. And then we see here that the next step is to write the answer generated by the large language model. And then we display a message saying done if everything succeeded. And this is the app. And then we can proceed to run our application. So here I did Streamlit run and then specify here the path of our application. So let's go back to our app by clicking on this button. We can already ask questions to the large language model because during the demo presentation, I showed you how this application works and we added the documents to Quadrant. So if we go to Quadrant, we can see that we have this collection here, which is called RAG PDF Reader, and we have all the chunks of our PDF document. Here we have the metadata, the page content, the vectors, and the length of the vectors. And we could ask more questions to the large language model that is currently interacting with all the PDF documents that we have in our folder, such as when does a player get a yellow card? And here we can see all the reasons why a player gets a yellow card. In this video tutorial, I show you how to build a RAG application that can work with any of your PDF documents. I showed you how to ingest data in Quadrant, how to use LangChain to streamline the workflow of your RAG application, and also to use Groq for fast inference, and also how to design the front end of your application using Streamlit. I hope you liked this video tutorial, and if you have any type of questions, please leave them in the comment section below. Don't forget to subscribe to the channel because it helps me to create more content. Smash the like button below and turn on the notification bell so you don't miss out a new video. See you next week.